Hello students, this is Srimati Sri Ramadevi, School Assistant Physical Science, JPHS Pedambarpet, Abdullapur Met Mandal, Rangareddy District. Now today we are going to discuss for the 9th class students, Physical Science subject, Chapter 4, that is Refraction of Light at Plane Surfaces. And in this chapter, we are going to discuss the recap of the refraction and what is refractive index. We are going to know in this chapter. And there are two types of the refractive indexes, that is absolute refractive index and the relative refractive index. We are going to know what is that, and we are going to do some problems on this refractive indices. Okay students, right, shall we start? Okay, now in the previous section we have seen that when the glass slab is placed over some printed letters, we have seen that the letters appear to be raised when viewed through the glass slab, isn't it? And we have already concluded that this is because of the refraction. We have noticing that the letters are raised from the actual distance, isn't it, students? Now, in this picture, you are saying that there are three different types of solvents are there: water, kerosene, and turpentine oil. Now, we have dropped a pencil over here in the three liquids. We are seeing that there is a bent in the uh, three solvents, bent of the pencil, which is more in the all the three solutions. Now we are seeing that at the interface there is a bent. So now today we are going to discuss what is the uh, quantity which is going to be measured in this. How can we measure how much this is bending, isn't it, students? Right. For that, and what is the reason behind this? Why we are seeing the bent over here? That is because of the refraction of the light from through the observer, right? Now what is refraction? Refraction is the change in the direction of the light as it passes across the boundary separating two media caused by its change in its speed. Okay student, now this black line refers the boundary separating the two medias. Either it may be air or the water or the glass, or it may be air, water or the glass. There are the two medias, and this is the line separating them. There is a change. This is the angle of, this is the light ray passing from one medium to the other medium. We are saying that there is a change in the direction of the light and change in the speed, and there is also a change in the speed, and this um, we call this as a refraction. Now, if there is a change in the direction of the light as it passes across the boundary separating two media caused by its change in its speed, that term itself is called a refraction. The bending of the light is called a refraction. Now, we are seeing that red dotted lines is the normal line. Normal line drawn on the boundary which is separating the two medias, and this is the angle of the incidence. This is the light ray which is falling on this, and the angle made between the normal and the light ray is called the angle of incidence, and this is called the refracted ray, which we have already learned that this is the angle of refraction. Angle made between the normal and the refracted ray is called the angle of refraction. Now we are seeing that angle of incidence is more and angle of refraction is less. It is bending more with the interface. The light is bending more towards the normal. Now that is called the refraction. Okay students, right. Now see, the letters are also appear to be raised when the glass slab is placed, isn't it students? Now when the torchlight is falling on the glass slab, what is happening? The path of the light is also changing. The We are saying that there is a bend in the light. Okay. Now, when the light is coming from the glass slab to the air media, then what happens? Then also there is a change in the direction. See, you are seeing that the light has to come like this, but it appears to be coming like this, isn't it, students? Now there is a change in the direction and also the change in the speed, which is called the refraction. Now, today we are going to discuss about how much will light bend in different media. So, in the glass slab, it is how much it is bending, and in the water, how much it is bending, and in the other liquids, how much it is bending. That we are going to see now. We are going to measure now. So, the amount of bending which when light travels from one medium to the another medium can be measured by the physical quantity called refractive index. So we have to measure how much it is bending. So how much the light ray is bending in its angle, that should be measured by a physical quantity called refractive index. Now this is the new word which we are learning here. Okay, students, right. Now you understood what is refractive index. What is it, the term mean? It is the amount of bending when the light rays travel from one medium to the another medium. It can be measured by a physical quantity which is named as refractive index. We are measuring with the physical quantity. We are measuring the refractive index of the in terms of the amount of light, how much it is bending, that we are measuring by this refractive index. Okay, students. Right. Now, already we have seen that when the light travels from the rarer medium to the denser medium, the velocity will be changed. The velocity in the rarer medium will be more. When the velocity of the light, when it entered into the denser medium, it will be less, because the light rays travel slowly and it is towards the normal. The bend is towards the normal. Therefore, V1 is greater than V2. And here also we are saying the same thing. When the light ray is entering from the denser medium to the rarer medium, the denser medium velocity is V1 and the rarer medium velocity is V2. Now here also in the rarer medium, we are seeing that the velocity is more because it is going away from the normal. Isn't it, students? So in the rarer medium, we have come to know that the velocity will be more. V2 is greater than V1. In the denser medium, always it will be less. Isn't it, students? Right. Now, the refractive index is of two types. One is absolute index and the other is relative refractive index. Okay, now first we'll study about the absolute refractive index. Now, what is absolute refractive index? When the light ray travels from the vacuum to the another medium, then the refractive index is known as the absolute refractive index. So there are the two mediums. One is the vacuum and the other medium. It may be glass, air, or it may be some oil, kerosene, different medium, whatever it may be, glass slab, whatever it may be. The refractive index, when the light ray traveling from the vacuum to the another medium, that refractive index is known as the absolute refractive index. Okay, students. Right. Now, absolute refractive index is the ratio of speed of the light in the vacuum to the speed of the light in the medium. We are comparing the speeds of the light in the vacuum and in the medium. The ratio of that gives us the absolute refractive index. Absolute refractive index is denoted by the letter N, and we know that the ratio of the speed of the light is denoted by the letter C, and the speed of the light in the medium is denoted by the letter V, V medium, or else C by V. Okay, right. Now here we are seeing that the speed of the light in different mediums. So we have taken some materials, vacuum, air, ice, water and the glass. Now the speed of the light. In the vacuum it is 300,000 kilometers per second. In 1 second it is traveling 300,000 kilometers in vacuum. Whereas in the air, the speed of the light is 299,000 kilometers per second. In 1 second, it is traveling 299,000 kilometers. Whereas in the ice, it is lower, that is 229,000. Whereas in the water, 225,000. In the glass, 197,000. For 1 second, it is traveling these many kilometers. So now when we want to calculate the refractive index of the glass, the formula is given by, just now we have studied that absolute refractive index is equals to the ratio of the speed of the light in vacuum to the speed of the light in the medium. Now we are comparing the vacuum with the glass. So speed of the light in vacuum by speed of the light in the glass. Vacuum speed of the light in the vacuum is denoted by the letter C, and the speed of the light in the glass is denoted by the Vg, because glass is the medium here. Now we are calculating the refractive index of the glass. Therefore, Ng. Ng is equals to C by Vg. Okay, students. Now, if we want to calculate the refractive index of the air, okay, for the glass we want to calculate. So, refractive index of the glass, C by Vg. What is C here? In the vacuum, if we know that it is a 300,000, means 3 into 10 to the power of 8 meters per second. 300,000 kilometers means already 5 zeros are there, into 3,000 into 1000. So 33678, 3 into 10 to the power of 8 meters per second. Okay, students. The speed of the light in terms of meters per second in vacuum is given as 3 into 10 to the power of 8 meters per second, divided by Vg. How much is the Vg? 197,000. Okay, 300 divided by 197,000. How much we are going to get? 3 zeros cut. 300 divided by 197, we are going to get 1.52 something. So the refractive index of the glass will be 1.52 or something like that. Okay, students, we can calculate the any refractive indexes of the materials with respect to vacuum. Okay, students, right. The absolute refractive index of any medium can be found out by the formula N medium is equals to C by V medium. Just now we have found it for the glass. If the speed of the light of the in the medium decreases, naturally the refractive index increases because it is inversely proportional. Okay, students. Medium is dense medium. We say that it is the dense medium. If the velocity of the light in the medium decreases, then the refractive index of the medium increases. Follow this? The speed of the light in the medium decreases, then the refractive index increases. Okay, students. Now, the other refractive index we are going to study now, that is relative refractive index. Now, what is this relative refractive index? There is something relative. Relative means there are two quantities which are in relative. Okay. When the light ray travels from the one medium to the another medium, then the refractive index is known as relative refractive index. Now we have seen that when the light ray travels from vacuum to the other medium, then it is called the absolute refractive index. Now, when the light ray travels from the one medium to the another medium, then that type of refractive index is known as the relative refractive index. Now, that can be measured as the ratio of the absolute refractive index of the water to the absolute refractive index of the air. So, relative refractive index of the water with respect to air is given as NWA. WA is the water, is equals to absolute refractive index of the water by absolute refractive index of the air. Okay, students. Now see here, when the light traveling from the one medium to the other medium, here we are seeing from the air medium to the water medium, there is a bend over here. Actually, it should pass like this, but there is a bend. So this is the refraction, isn't it? So That refraction is measured by the physical quantity refractive index. Now there is a relative refractive index between the air and the water. Therefore, we are calculating it like this. NWA is equals to N water by N air. These N's are absolute refractive indexes, whereas this NWA is the relative refractive index. Okay, when compared to water and the glass, we are seeing that N glass by N water when we calculate the relative refractive index of the glass. N water by N glass, then that will be the relative refractive index of the water, isn't it? Okay, that we call it as relative refractive index of the water with respect to the air. Now, the relative refractive index of the water with respect to the air is given by NWA is equals to absolute refractive index of the water by absolute refractive index of the air. Now we know that absolute refractive index is equals to C by VW. We know that the speed of the light in the vacuum by speed of the light in the water medium. So similarly here, now dividing these C's, we get VA by VW. Okay, students, sorry. Refractive index of the medium 2 with respect to medium 1 uses the relative refractive index, that is equals to velocity of the light in the medium 1 by velocity of the light in the medium 2. The refractive index of the medium with respect to vacuum, that is absolute refractive index, the velocity of the light in the vacuum by velocity of the light in the medium. We know that the velocity of the light in the vacuum is 3 into 10 to the power of 8 meters per second divided by velocity of the light in the medium. Okay, students, this is the absolute refractive index and this is the relative refractive index. Now you came to know that the two types of the refractive indices here. See here, the relative refractive index is the comparison between the two mediums. Therefore, we have to write it as N21 is equals to N medium 2 by N medium 1 is equals to V1 by V2. If V1 is greater than V2, then we say that the medium 2 is the denser one. Now, if V2 is greater than V1, then we say that then medium 1 is the denser one. Isn't it, student? Right. Similarly, see here, we are going to see here. If N21 is less than 1, then medium 2 is the rarer medium than the first medium. Okay, students. Right. Now here is a comparison and a question for you. That is, the refractive index of the glass with respect to air is given as 1.5 and the refractive index of the diamond with respect to air is 2.4. In which medium would the light bend more? The indexes are given, the measurement is given. They are asking that in which medium the light will bend more. Okay. The refractive index of the diamond is 2.4 and for the glass is 1.5. Let us see in which medium the light bends more. Okay, see for it. In this diagram, we are seeing the normal and this is the boundary of the two separating mediums. Now this is the incident ray, angle of the incidence is I and the angle of refraction is R. And this is the RD. RD is the angle of refraction in the medium diamond, in the diamond medium. Okay, RD. Now there is a bent over here. So the refractive index of the diamond with respect to air is 2.4. Isn't it, students? Then what happens? What is refractive index? We know that the velocity of the light in the air by velocity of the light in the diamond. Similarly, refractive index of the glass with respect to air is given as velocity, speed of the light in the air by speed of the light in the glass. isn't it, students? So cutting these numerators, then we get reverse. Velocity of the light in the glass is greater than velocity of the light in the diamond, isn't it? The speed of the light in the glass is more and the speed of the light in the diamond is less. So see here. Now you are seeing here the diagram. This is the angle of the incidence and the two angle of refractions we are saying here. RG is the refraction, angle of refraction of the glass, and RD is the angle of refraction of the diamond. Now you are seeing that the angle is more for the RG and angle is less for the RD, isn't it? So angle of refraction for the glass is more, angle of refraction for the diamond is less. What does it mean? If the angle is more, the bent is less. Isn't it, students? From the interface, the boundary, from the boundary line of the two separating media, the bent is less. So for the glass, the bent is less, and for the diamond, the bent is more when compared to with the diamond and the angle of refraction. Here the bend is more. That means we know that light bends more in diamond, isn't it, students? As the angle of the refraction increases, the bending of the light decreases. So for the glass, it is the angle of the incidence is more. Angle of the refraction is more for the glass. Angle of refraction is less for the diamond. Therefore, we are saying that the bent for the diamond is more. The light bends more in the diamond. Now see here, students. Now we compare the two medias here, oil and water. In which media the light is traveling more? We'll compare here. Wow, yes, we are seeing that in water, the light travels faster, and whereas in the oil, the light travels slower, isn't it? So we'll see here. The medium in which the light travels fast is the less optically dense. Now, which is the less optically dense here? Light traveling fast in this. So light traveling less slow in this. So this is optically dense, and this is optically dense, more optically dense, and this is less optically dense, isn't it, students? The medium in which the light rays travel very slowly is more optically dense. So this is more optically dense, this is less optically dense. Now what is this optically dense means? For more refractive index, there will be the more refractive index, and the speed of the light rays will be less. Now, what is density? Density is the mass per unit volume. Now, this we call it as mass density. Now, mass density for the water is more. And for oil or the kerosene, mass density is less than the water. But the refractive index is more for the oil. So, optically denser than water. Okay. Have you followed, students? Right. So in this also we are, the refractive index is more, the bent will be more. The refractive index is less, so the bent will be less. So here you are understanding this. Okay, students. Now, why this is happening like this? Why there is the refractive indices are different for the different materials? What's happening? So we'll discuss that. Why do different material media possess different values of the refractive indices? Because refractive index is depending on the some factors. What are those factors? Let us see. See, we are seeing here air, ice, water, kerosene, turpentine oil, glass, benzene, rock salt, ruby, sapphire, diamond. So these are all the materials given here, and refractive index are also given. For the air 1.003, for the ice 1.31, for the water 1.33, kerosene 1.44. So different material media possess different values of refractive index. So what is that? On what factors they are depending? Let us discuss. Okay, students. Factors affecting the refractive index of the medium. Now, to discuss this, first we have to know what is refractive index. We know that the absolute refractive index is equal to the speed of the light in the vacuum by speed of the light in the medium. Okay, the refractive index Ri is directly inversely proportional to the 1 by speed of light of the medium. So speed of the light in the medium is more, then the refractive index will be less. If the speed of the light in the medium is less, then the refractive index for that medium will be more. Okay, it is inversely proportional. Okay, students, now we'll discuss what are the factors affecting the refractive index. There are three factors. First one, nature of medium, that is optical density and the temperature. And the third point is color of light, which is wavelength. Okay, now what is this nature of medium and how it is dependent? If the medium is rarer medium, then the speed of the light will be high. The velocity, we know that the velocity in the rarer medium is more. When compared to the denser medium, it will be less. So we know that speed is inversely proportional to the refractive index. Therefore, Ri will be less in the rarer medium and refractive index will be more in the denser medium. Isn't it, students? So this is the optical density. Right. Next, second factor is the temperature. As the temperature increases, we know that the speed of the light increases, and we know that the speed is inversely proportional to the refractive index. Therefore, refractive index decreases. As the temperature decreases, the speed also decreases. Therefore, refractive index of the medium increases. Isn't it, students? And finally, third point is the color of the light. Wavelength, which is nothing but wavelength. The third factor which is affecting the refractive index of the medium is the wavelength. Now, we know that for 7 colors, for all the colors, the speed of the light for all the colors in the vacuum is same. But whereas in the medium, for the separate mediums, the speed of the light changes. The speed of the light, for example, for the red, the speed of the light is more, therefore refractive index will be less. And the speed of the light for the violet region, it is the less, therefore refractive index will be more. Follow, students. Right, with GR, for the 7 colors we have seen the speed. Speed of the light in the vacuum is same, but in the medium, for the red it is more and for violet it is less. Therefore, it is reversed for the refractive indices. Okay, students. Now we'll see some questions here. The speed of the light in the diamond is 125,000 kilometers per second. What is its refractive index? The speed of the light in the air is given as 3 into 10 to the power of 8 meters per second. Now we have multiple choice. A is equals to 1.2, B is equals to 2.4 and C is 3. What is the correct answer? We have to choose. Now we know that what is the refractive index? The refractive index, what is the formula for that? It is the speed of the light in the air by speed of the light in the diamond. Yes. So we'll see here. So N is the refractive index of the diamond, which is given as speed of the light in the air by speed of the light in the diamond. So what is the speed of the light in the air is given 3 into 10 to the power of 8 meters per second divided by 125,000 kilometers. We have to change this in the meters. Therefore, into 1000 we are going to get. So, into 1000. 3 more zeros we have given. Now, 6 zeros down, 6 zeros up are going to get cancelled. 3 into 10 to the power of 8 means after 3, 8 zeros. Okay, students. 6 zeros get cancelled. 300 divided by 125 gives us 2.4. So B is the answer. The refractive index of the diamond is 2.4. Isn't it, students? Have you followed? Next, coming to the another question, that is the refractive index of the water is given as 4/3 and the refractive index of the glass is 3/2. What is the refractive index of the glass with respect to water? Now this is given with respect to air. Now we have to calculate refractive index of the glass with respect to water, comparing between the two medias. So this is the relative refractive index, isn't it, students? So what is the formula for the relative refractive index? So relative refractive index of the glass with respect to water is equals to Ng by Nw. Ng is given as, for the glass, the refractive index is 3 by 2, and for the water, the refractive index is 4 by 3. Okay. Now taking the denominator up, so 3 into 3, 9, divided by 4 into 2, 8. So that gives us 1.125. So A is the correct answer. Okay, students. All right. One more example we are going to see here. If the speed of the light in the medium decreases, then what happens to its refractive index? Well, yes, if the speed decreases, the refractive index increases. If the speed increases, the refractive index decreases. Okay, students, have you followed all this? Thank you. Thank you for watching.